We're going to be looking at example 4 in our section 4.1 notes. I went ahead and drew the triangle and filled in what we knew. We have that angle B is 22.6 degrees, side A is 13.8, and side B is 5.55. This is a side-side angle triangle because of what we're given. The angle and then the two sides. So we can have 0, 1, or 2 triangles in this case. So we need to find angle A, angle C, and then across from angle C, we need to find side C. Okay, so it makes sense to find A first because we don't know anything about C at this point. So that's going to be our first step. Okay, so using the law of sines, we're going to have 13.8 all over the sine of A, and then we're given both pieces of information for B, so we're going to have 5.55 all over the sine of 22.6 degrees. All right, go ahead and cross multiply. We're going to get 5.55 sine A is equal to 13.8 times the sine of 22.6 degrees. Divide both sides by 5.55, and then also you'll need to take the sine inverse of both sides. So you're going to have A is equal to, once the 5.55 comes over here, I'll go ahead and make that happen. Okay. We'd have the sine A equal to this expression, but if we take the sine inverse, it'll cancel out the sine, and then the sine inverse will show up in front of our expression. All right, putting this in our calculator, we end up that A is approximately 72.9 degrees. Make sure your calculator is in degree mode. Okay, so we have one piece of information, so we definitely know that we have one triangle at this point. So I'm going to go ahead and solve that first triangle. All right, so I'm going to call this A1, so 72.9 degrees, so that part is done. All right, we also need to find the last angle, which is very easy. So C, I'll call that C1. We'll take 180 degrees minus the 72.9 we just found, and then we have angle B is given, so we'll subtract off that. Okay. Putting that in, we end up with 84.5 degrees for angle C. All right, so our last thing that we need to find is side C, and this will be another law of sines application. Pardon me on that. So I'm going to call that little side C1. So C1 over the sine of angle C1 at 84.5 degrees. And then I'm going to use angle B information since that's given to me. So 5.55 for side B all over the sine of 22.6 degrees for angle B. I just need to multiply both sides by the sine of 84.5 degrees. So I have 5.55, the sine of 84.5 degrees, all over the sine of 22.6 degrees, and side C1 ends up being about 14.38 when you put that expression in your calculator. Okay. So that's our first triangle. So now we're going to check and see if there's possibly a second triangle in this case. We need to use the angle that we're given. Remember that the sine has positive answers in both the first and the second quadrant. So we definitely have a first quadrant angle here. To find our second quadrant angle, we're going to take 180 degrees minus the 72.9 that we found. So a possible A2 is 107.1 degrees. Okay, now here is where we see that it's valid. So we know that there's 180 degrees in a triangle, so we need to see if there's enough room for this third angle, for this third C here that we have here. So 180 degrees in the triangle, the 107.1 that we just found, and then the 22.6 degrees that were given. So if you end up getting a positive answer here, then you will definitely have a second triangle. If you end up doing this computation and you get a negative answer, that tells you there wasn't enough room for this angle, and you can be done. Okay, so when we do subtract, we do get a positive angle, so we get 22.6 degrees. So that tells us that there was enough room for this third angle in the second triangle. All right, so we need to finish solving, so we're going to be finding side C2. Okay, all over. Excuse me, this computation was wrong, so accidentally copied that. So this is actually 50.3 degrees. All right, so we're going to use this here. So the sine of 50.3 degrees. Okay, once again, we want to use our angle B information because that's been the consistent part of this problem. So we have 5.55 all over the sine of 22.6. Okay, we're going to multiply by the sine of 50.3. So we have 5.55 times the sine of 50.3 degrees all over the sine of 22.6 degrees, and side C2 ends up being about 11.11. Okay, and that completes example 4.